estás? Hey, Mr. War here with another math video. Welcome to the new land and my alien friend, and let's go ahead and get started. Yes, let's not waste any time. Woohoo! Look at that. Looks like we got the Christmas season going on here. Let me see here. Little bell here, little bell there. Yeah. Right on. Topic C, we're still looking at making like units numerically. Very important. Topic, as you can see, we've been actually adding. Oh, phone going off here. Now, students will be able to add fractions with sums greater than 2. Nice. Okay. And yes, that seems pretty straightforward, that objective, wouldn't you say? I would say so. All right, let's take a look at our application problem here. Application problem here states, so let me get my magic pen. You never know when I might need it. Hint, hint. Anyways, to make punch for the class party, yes, this is what we're hoping for, huh? Mr. Warren mixed 1 1/3 cups of orange juice, 3/4 cup of apple juice, and 2/3 cup cranberry juice, and 3/4 cup lemon. Like, this is my special recipe. Anyway, it says mix together. Ooh, that's kind of a hint right there. We're talking about some addition, right? Wow, that was pretty cool. Never seen you do that before. Anyways, how many cups of punch does the recipe make? All right, and there's a bonus question down here, which we'll look at later. But first thing, we're always looking at that reading and understanding the problem. And, of course, drawing, representation, of course, writing. And writing our explanation could be our mathematical reasoning, that kind of thing. So let me go ahead and get a regular pen now and take a look at this. Let's go ahead and try to show the drawing part, along with how, as we read the problem, putting it into some kind of, we call this the tape diagram, but some kind of representation, a picture, helps a lot. Now, I'm just going to go ahead and show this first here. It looks like we have 2. It looks like we have 1 that's 1 1/3 cup, 1 1/3. Oh, and the rest of just looks like just fractions. So I'm going to say that I'm going to go ahead and just start off here and just call this 1 1/3 cups. Okay, and this is the OJ. And then we have a 3/4 cup, and we'll make those about the same. Although this doesn't really matter, we're just trying to show this because 1/3 cup, 3/4 cup is apple juice, and then of course we have another 3/4 cup here of soda, and then 2/3 cup of, looks like cranberry juice. We'll just call CJ. Okay. So something here, looking at this right away, something that I'm noticing here is that we have thirds. See, and that's the unit for that fraction. Here we have quarters. So what I'm kind of thinking here is, bring this down here, I'm thinking that maybe we could add the, let me get the eraser here. We could add the similar unit fractions, the fractions with the same unit, first. Make sense? So here we could add the thirds together and we could add the quarters together. So I'm going to go ahead and list that out, 1 1/3. And then I'm going to go ahead and let me put the whole problem down the way that it's actually listed here, plus 2/3 plus 3/4. Okay, we don't know what that's going to equal, and I'm just listing them out here. So now we can join them. So we could actually say, well, let's go ahead and join, and this is the associative property, if you recall. We're going to go ahead and take the 1 1/3 and add that to the 2/3. And then go ahead and take the 3/4, which we have twice, and do it as such. Let's go ahead and continue with our red pen. So now, again, we've brought these together. Now, if you look at this, we have 2/3 and 1/3. We've counted by thirds before. 1/3, 2/3 is 3/3. And again, 3/3 is equal to 1. Okay, that's pretty simple. Now we have that 1 already here, and then we've got another 1, so that's 2. I like that. And then over here we have 3/4 and 3/4. Well, we have the same unit here in the bottom. We could call that 6/4. 3 plus 3 is 6 over 4. And of course, to make one whole, we would need 4 over 4. Because 4 again over 4 equals 1. So we have that. We'd have 1. Now, we have 6/4, so 4/4 is 1. So we'd have 2 left over, so we would have 2/4. We'll just put it down like such. So now we have 2 plus 1 and 2/4. Well, here now we can add the 2 and the 1 together, giving us 3. And then we have 2/4, which is equal to, our 2/4 here is equal to 3 1/2. Because we're familiar that 2/4 is equal to 1/2, an equivalent fraction. So the recipe here then, so now the bonus problem says here, it says each student drinks 1 cup. Well, did you get that? I hope so. It always tries to do that. Okay, I just need 1 of these, okay? Not 2 of them. Just 1. All right. Goodbye. Yeah, we'll go ahead and get by. So for the bonus, it says each student drinks 1 cup. How many recipes does Mr. Warren need to serve his 20 students? Well, you guys are actually 30. We could do 32. So if this is 1 recipe for 3 1/2 cups, you can see that, definitely 3 students could drink that. There would be a 1/2 cup left over. So what's that asking us to do? Well, we're basically saying, well, we're going to take the number of students here and divide it by the actual recipe for 3 1/2 to see how many. And that's just 20 divided by, in this case, it's going to be 3.5. Okay. And we could do the math and figure that out. And should we do that? I think not. I think for right now, we're just going to go ahead and move on to the next problem, only because we have a lot to get to. All right, here we go. So here we have our concept development. This is what we're really kind of focusing on here for our lesson about adding fractions with sums greater than 2. And our sum, obviously the addition problem, is going to be greater than 2. First thing here, I just kind of wanted, I put these 3 problems up here, and I want you to see, what similarities do you notice about these problems? When you're just kind of looking at them. You might notice that, look at this first add-in, these are identical. Okay, you might also notice that we have fifths here. So these have the same denominators, whereas these two don't. These have fifths and halves. Okay, it's just something to kind of notice when you're looking at a problem. So, what's that? A turkey? Oh man, look at that. Oh, now I'm hungry. Hello, turkey. All right, see you later, buddy. We gotta let you go. Sorry. Now, when we take this problem here, what we're going to do here is look at this, and right away you can tell by looking at this, we have that whole number part, and we have the fraction part. We know we can't add these together because we don't have the same denominator. So we could change the fifths maybe into another unit that both the 2 and the 5 share. And we did this before in a previous lesson. And by looking at that, you might see right away that, well, if I have fifths and I have halves, there's a way that I can give that the same denominator. Okay, and the denominator would be 10. And if we, in the old days, I should say, not the old days, not too many lessons ago, we did halves, showing that unit, and here we show fifths, right, going across. And if we overlap those, we realize that we could get tenths. Another way that we could do that is we could say, well, I'm going to just take the 1/5 right now and just say, well, I'm going to say the 1/5. I'm going to multiply that, okay, by the 2 for 2 over 2. Now keep in mind, 2 over 2 is equal to 1. So the identity property of multiplication states that any factor multiplied by 1 is going to be that number. So 2 times 1 equals 2. Any number multiplied by 1, remember, and 2 over 2 is 1. So we're not changing the value of this number. We're still going to have 1/5. However, when we multiply the numerators, we get 2. And when we multiply the denominators across, we get 10. So now we have 2 tenths. Okay, now we're going to do the same thing for the half. Okay, now for the half, we're not going to multiply by 2. We're going to multiply it by the 5, because this is what we were doing over here, changing the fifths into halves. Now we're multiply 5 over 5, because what we multiply by the denominator, we have to multiply by the numerator too. Otherwise, you're going to change the value. 5 over 5 is 1, therefore we're not going to change the value. Now when we multiply across, you can see we get 5 over 10, and 5 over 10 is a half. Now let's go ahead and just do the math. We'll come over here, and you can see that what we have now is we have 2, and then this was the 1/5 right here, so that's going to be the 2 tenths, plus, and then we had the 1. Remember, the 1/2 over here we decided is 5 tenths. Now we have 2 fractions with the same denominator. And of course the 2 plus the 1 is 3. We can add the whole number part. And then of course 2 plus 5 is 7. And that gives us the 10. Okay, so we get 3 and 7 tenths. Pretty straightforward. And we could show this, I just did this really quickly, I could show this on a number line as well, like we had done before. You know, showing 0. Okay, it turns out here that this would probably be a good idea to put 4. That means in the middle would be 2. Now we have 1, and of course we have 3. Now we're showing this, we could say, well, let's use the original problem here. You had halves, you know, we had fifths, so you could show the 2 and 1/5. But then you would realize that, okay, even if I divide this into fifths, okay, 1, 2, 3, we're going to just come to the first part, 2 and 1/5, then we're going to need to add the halves, the 1 1/2. So this is where it would be better to put this into tenths so that we could add that. Okay, I'm just kind of showing you the number line. Let's move on to the next problem here. Now you might look at this one here and say, you know what, the similarity, we have 2 and 4/5, and that's that problem over here. And if you look at this one, what does that have in common with this one over here? Okay, they're both fifths here. What's kind of interesting here, if you look really carefully, you'll see, oh wait, Santa! Hey, Santa, how are you doing, my friend? Hey, where's your sleigh? All these pictures coming up on my screen. Okay, so if you notice, we have, so if you look at the 4/5 and the 1/5, you can see right there, that's going to make a whole. Okay, 4/5 because we counted one more, we had 5/5. So let's kind of do the exact same thing that we did. 2 and 4/5. Let me rewrite it over here. I need to feel like I have my problem written down. Okay, so now what we have here is we could, like right away, leave the half over here and just add this part. We could do that. For some reason, I want to do that. There's just another way you could do that. Now looking at the fifths and the halves, we already determined that tenths works really, really well, so we're going to make tenths. Well, here we could put the 3, and then I'm just going to put in parentheses, just kind of separate this out, that we're going to actually take 4/5, and we're going to actually multiply that by 2 over 2. Now the reason why I'm doing that is because, remember, I had fifths and halves. In order to get that same unit in the same denominator, I need to get the 10. And so by doing that, it's almost like my fifths here. If I double it, multiply by 2, I'll get my tenths. Therefore, I'm going to multiply that by the 2 here. This one here, plus the 1/2, I'm going to do the opposite and multiply it by the 5. Okay? This is what we did in our last problem. Now we have our 8 tenths, and that's not multiplying. Okay, I want to make sure that you guys know that. Normally that would mean that, and then here we have our 5 tenths. I think 5 tenths looks right. Half, yes. Just double checking my work here. Now when we add those, you can see we get 3, and now we have 13 over 10. Well, we have more than one whole here because we keep talking over and over again. If you have the same numerator as the denominator, that gives us always one whole. And we have 13. That's over 10. Therefore, we have another whole sitting there. So we're going to take that one whole out. That's the 1. And it's going to leave 3 left over. Okay, 3 left over. So 3 over 10. Therefore, we can add those now and get 4 and 3 tenths. Okay, seem pretty simple. And let's extend that so there's no confusion. Okay, so let's go ahead and look at another problem. Oh, this is Christmas. Now, in this particular one, let's do this. Let's look at this problem and say, well, again, we have 2 fractions with different denominators. We can't add those when that happens. Okay, so let's look at this, and as you can see, we have this equation listed down here below with your less than symbols here. What we want to do here is we want to do like a quick little estimate to determine what our answer, what would be a reasonable answer to this problem. And, you know, we're looking for a number that's going to be less than, it's going to be less than this quantity, but the number is going to be greater. It's like looking to a range between like 2 and 3. Is the answer going to be? The answer is going to be definitely less than this, but not greater than this other number. So, that being said, you see we can look at the 2 and the 5. This is really just a quick estimate. So that gives us 7. However, we have 2/3 and we have 2/5. Well, kind of hard to tell. 2/3 would be the same as actually 4/6. Kind of hard to tell. It's more than half, and this one's a little bit less than half. So I'm thinking that will probably give us 8 because 2/3 is pretty large. So I'm going to say that it is going to be that the answer is going to be greater, okay, greater than 8, but I don't think it's going to be greater than 9. Because I'm looking for a range here, just kind of get an estimate so that when I do my answer. So let's go ahead and do this one. So 2 and 2/3 plus 5 and 2/5. Again, we're looking for that common denominator. So what I want you to see is that 2/3 and 2/5, well, the 3 and the 5, of course, when we multiply them, that gives us 15. And if you had our grid and we had thirds and fifths, that would give us a new unit and denominator of 15. Now, in order to get that 15, remember, I'm taking 2/3 times, okay, 5 over 5. And with 2/5, I'm going to be multiplying that by 3 over 3. Doesn't change the value to give you my 2 new fractions here. So this would be 10 over 15, equivalent fraction. And this is going to be 6 over 15. Now I'm going to go ahead and put that 2 and 10/15 plus 5 and 6/15. Now I have the same denominator. I can add them together. And let's do the whole part first. 2 plus 5 is 7. 10 is 6 is 16 over 15. You may notice right away that we have more than one whole here. Okay, we have the 7 plus the one whole that we're going to get. I have 1 left over, and now you can see we'll get 8 and 1/15. Okay, doing our quick estimate, we have 3 and 6, that looks like 9. 5/7, definitely more than half. 2/3, definitely more than half. So you can start to see a range our 9. This is definitely going to give us a 10. Does that make sense? Because it's more than half, definitely give us a 10. So this is going to be greater than 10. So I would probably say that it's reasonable to think that if it's greater than 10, but not going to be greater than 11. Now, if we start to do our work, you can see that we have 7ths and we have 3rds. When we overlap those two, and 3rds over 7ths, that's going to give us 21 equal units when we do that. So that means we're really taking the 5/7, and we're going to multiply that by 3 over 3, and we're going to take the 2/3, and we're going to multiply that by, 7 over 7, the opposite, to get our two new equivalent fractions, 15 over 21, and in this case we have 14 over 21. So we could use those new equivalent fractions. So we're going to have 3, and the 5/7 is going to be equal to 15 over 21. We're going to add our 6 whole number part, and our new equivalent fraction here was 14 over 21. So that's going to give us 9, and then if we add those, we get 29 over 21. I'm going to bring this down here. Now we have our 9, but look at this. We have a full like one whole here, so we can take that 21 over 21. So that's going to give us one whole, and then that's going to leave 8 left over. So 8 over 21. Oh, and then we need to add that 10 over 8, 21. And there is not a common factor between the two, so then that would be the answer. Okay, and I believe I owe you a whole bunch. And that should do it, my friends. This completes this video. A lot of just skill work today, looked like to me. But we added fractions with sums greater than 2. Adios, my friends.